It's been a while since we last had class, so it's not very clear when we can also meet next. So I thought I'd make some lectures using the slides that already have been prepared for this material. So we have successfully finished half of unit 1 and then unit uh, 5, and we will continue with unit 2 onwards, and then we will continue with unit 2, 3, 4. So we will start with unit 2. We have the slides here, so you can note down some points as you think is important, and also I will mail these slides to you also later on. And I also have a simple whiteboard which I'm going to use. I'll show it to you in a second. It looks like this, and this we can use for simple things, not too complex, unfortunately. And together with this and the slides, we will see how far we can go. And obviously, we will come back to this material again after college reopens. And we will explain this, but just so that I don't have to rush too much at that time, we will use this as the first iteration. Okay, so like I said, we will start with unit 2, which you see on the slide here. So unit 2 is all at the circuit level. So if you remember from the definition that we talked about early on in this course, circuit level means we are dealing with transistor level circuit diagrams, not at a block diagram, not gates, etc. So most of the material is going to be at the circuit level itself, and the main focus of this unit is timing. So we have a lot of information already about CMOS circuits. We know how to create CMOS circuits, etc. And we have gates, and we know how to convert the gates into circuits. Now, in this unit, what we are going to do is, given a particular gate, we are going to try to find some way in which we can measure the quality of the gate in terms of timing. So if the gate is very fast, then obviously it is going to have a good quality, that is good timing. If the gate is very slow, then the timing is going to be bad, etc. So that is the simple overview in terms of gates. We are also going to do some other things. In particular, we are going to look at different types of delay models, or what is called as delay models, which is just ways to measure the delay, different ways to measure the delay. And one thing that is important to know at this point, the most important thing we are going to do is how to predict the delay given a circuit. Okay, that is the first part. Obviously, given a circuit, every time we cannot do the synthesis. I know that there are synthesis steps. I can create Verilog code and give you the delay exact number, but that is not very important. What is more important is some approximate measure. Okay, but I can just do it by hand. I don't need to go to the computer. That is what is called as hand calculation. And whenever we are working in some larger design, or if you are in a meeting or some other professional setting, nobody does synthesis. Okay, synthesis is a last step that is done at the end of the final design, when you're just ready to find out the final timing parameters. We do synthesis, but before all that, we do what is called as some hand calculations, and that is what this unit is all about. How do we do hand calculations in order to measure the timing of some design? And more importantly, how do we improve that timing? I know that obviously we can improve the timing by improving the design, but as okay, let me just stop here.